Hi, I'm Ms. Hall, and this is Lesson 8, Characteristics of Quadratic Functions, Part 1. In this lesson, we're going to focus on the axis of symmetry and how once you identify the axis of symmetry, you can quickly sketch the rest of the parabola. So axis of symmetry. An axis of symmetry is a line that divides a parabola into mirror images and passes through the vertex. Because the vertex of f of x equals, and that's vertex form of a parabola, is h comma k, the axis of symmetry is the vertical line x equals h. Previously, you used transformations to graph quadratic functions in vertex form. You can also use the axis of symmetry and the vertex of the vertex to graph quadratic functions written in vertex form. That was a lot. Let's do an example. In example 1, we're given a function f of x. We need to label the vertex and axis of symmetry. We need to graph it and label those two things. So this is in vertex form. In vertex form, I can identify my constants. I have a equals -2, which means that the graph is a reflection over the x-axis. I have that h is equal to -3, because you remember that the form is x minus h squared, right? A plus k. And so minus a -3 will result in x plus 3, and k equals 4. So the vertex is h comma k, which is -3 comma 4. -3 comma 1, 2, 3, 4. Okay. So there is my vertex, which is -3 comma 4. My axis of symmetry is x equals h, or x equals -3, right? Because h is -3. And I will sketch it. This is my axis of symmetry, my AOS, x equals -3. Okay, so the parabola is going to fold around that line. Now, how this helps us with graphing is if you imagine that we don't have a graphing calculator, we don't have access to it, we are going to find a few points and then use the axis of symmetry to double the amount of points we know. I am going to use an x value that's 1 away from the axis of symmetry and 2 away. So that is an x of -2. So I'm going to find f of -2 and an x of -1, f of -1. And I'm going to put that x value into the function. The function is -2 times x. So this is -2 plus 3 squared plus 4. And I have -2 times -1 plus 3 squared plus 4. Okay, so -2 plus 3 is +1. 1 squared is 1 times -2 is -2. So I really have -2 plus 4 is +2, which means I have the point -2 comma 2, -2 comma 2, 1, 2. And here's where I can use the axis of symmetry. This point is 1 space unit away from the axis of symmetry. And so 1 unit on the other side of this axis of symmetry will be another point on the parabola. And now let me find f of -1. So I have -1 plus 3 is 2. 2 squared is 4. 4 times -2 is -8. -8 plus 4 is -4. And if you need to use a calculator to do that, you absolutely can. So this is -1 comma -4. And that point is -1, 1, 2, 3, -4. And I'll use that the axis of symmetry folds the parabola in half. That point is 2 units to the right of the axis of symmetry, so 2 units to the left is another point on the parabola. And now I have a sketch of f of x. In example 2, we're going to graph again using the axis of symmetry, but now the quadratic function is not in vertex form, rather it's going to be in standard form. Standard form of a quadratic function is ax squared plus bx plus c. And when you're given a quadratic in standard form, we're going to find the axis of symmetry first. The axis of symmetry is negative b over 2a. So for example, in 2, we have an a value of 3, a b value of negative 6, and a c value of 1. So to find the axis of symmetry, we're going to take x equals negative b, b is negative 6, over 2a, a is 3. We have negative 6 over 6. A negative times a negative makes a positive. So we really have 6 over 6, which is really 1. So in this one, we begin, when we have it in standard form, we begin by finding the axis of symmetry, which is 1. X equals 1 is the axis of symmetry. To find the vertex now, we use our knowledge that the x value of the vertex is 1 to find f of 1. Well, what is the y value when x is 1? And we have 3 times 1 squared minus 6 times 1 plus 1. So this is 3 minus 6 is negative 3 plus 1 is negative 2. So we have the point 1 comma negative 2. 1, negative 2. This is the vertex. 1 comma negative 2. And now we need to plug 2 more x values into this function. So we get 2 more points that we can add to this graph, and then we'll use the axis of symmetry to put the symmetric 2 points on, and we'll have 5 points to make our parabola. I'm going to choose x of 0 and x of negative 1. So I'll be finding f of 0 and f of negative 1. Again, I am just plugging it into the original function. And 3 negative 1 squared minus 6. Okay, 0 squared, 0 times 0 minus 0. So this is really 1. So I have 0 comma 1. Negative 1 squared is 1 times 3 is 3. It's going to be 3 plus 6 is 9 is 10. So negative 1 comma 10. Okay, so I have 0, 1, and negative 1, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This point is 2 to the left of the axis of symmetry, so 2 to the right is another point on the parabola. This one is 1 to the left, so 1 to the right is another point. And this parabola opens upward. The a value is positive, so that makes sense. In our final example, we'll be identifying the minimum or maximum value of a parabola, and then where the parabola is increasing or decreasing. Looking at the core concept, if there is an a value greater than 0, that means the parabola opens up. So that vertex is the minimum value. And then for increasing or decreasing, we're reading the graph like we're reading a book from left to right. So as it gets closer to the parabola, the y value, closer to the vertex, the y values are decreasing. So we see this is where the parabola is decreasing. And then to the right of the vertex, the y values increase. So we say that that part of the parabola is increasing. Similarly, if the a value is less than 0, if you have a negative a value, it means the parabola is opening up downward. And here the vertex is the maximum value. And so to the left of the vertex, the y values are increasing. And to the right of the vertex, the y values are decreasing. Here's how this information will look on a question. Example 3, find the minimum value or the maximum value of this function. Describe the domain and range of the function and where the function is increasing or decreasing. Okay. We see that the a value here is 1/2. It's a positive 1/2, so we know that the parabola is opening upward. So we know this vertex is going to be a minimum value, and now we need to find that minimum value. Because we're given the function in standard form, we need to begin by finding the axis of symmetry, negative b over 2a, to get the x value of our vertex. Okay, so we've got negative b is negative 2 over 2 times a is 1/2. This is really 2 negatives make a positive. We have 2 over 1. So we know the x value of the vertex is 2. X equals 2 is also the axis of symmetry. And now if we plug in 2 into the formula, the function, we will get the y value of the vertex. Okay, so 2 squared is 4, half of 4 is 2, 2 minus, oh, that's not a square there, 2 minus 4 minus 1. 2 minus 4 is negative 2, this is negative 3. Okay, so we have a vertex of 2 comma negative 3. We say this minimum value, right? If I'm to sketch this parabola, and 2, negative 3 is somewhere like that, and it opens upward. We say the minimum value is the y value. So the minimum of this parabola has a minimum, and it has a minimum value of negative 3. Right? This is 2, negative 3. That is the lowest y value. Okay. Now let's review domain and range. Domain is all the possible x values that this function could have. X values, right, from left to right of this graph, and we could have all real x values, all real numbers. That is a shorthand for writing all real numbers. X could be any real number. The range is possible y values of this function, okay? And y will never go lower than negative 3. So we see that the range is y greater than or equal to negative 3. Now the new piece, increasing and decreasing, because the vertex is a minimum, we say that it is decreasing. So let me write decreasing to the left of the vertex, or to the left of x equals 2, and it is increasing to the right of x equals 2.